Hi, this is Alex Preka, and in this video, I'm going to explain to you sets in discrete mathematics. So, what is a set? A set is a collection of objects. We just think of a collection as crayons. And towards a more math aspect, we can say all the prime numbers, so prime numbers. This leads us to our next point is what is an element? An element is an object in a set. So we can say that there may be like a red, orange, and yellow crayon. We can just represent this as R, O, and Y for simplicity. And then for the prime numbers, the elements for the prime numbers are the prime numbers. So 2, 3, 5, 7, and so on. So we can see from these two examples that a set can have a finite number of elements or an infinite number of elements like the prime numbers. This brings us to our next point is how do we represent a set in the form? So the form is called roster notation, which is a list of elements enclosed in curly braces. So if we go back to our crayons example, we see we have a red, orange, and yellow crayons. So all we have to do is crayons is equal to, in our curly braces, red, orange, and yellow. The order is unimportant, so we can also represent this set as orange, red, and yellow. Also, repeating an element does not change the set. So if we have like 2 red and 2 orange crayons, we can also represent this set as orange, orange, red, red, and yellow. So in essence, all these sets are equal to each other. Number one, order is not important in this set right here. And in our third set, repeating an element does not change the set. So all these sets are equal. This brings us to our first practice problem in which we have to select the set that is not equal to Q is equal to 4, 6, 7, and 9. So if we look at option A, we see in Q we have 9, 7, 6, and 4. As I previously said in our crayons example, the order is unimportant. So we see in our first is 4, 6, 7, and 9, but it goes backward in A, so 9, 7, 6, and 4. So these sets are equal to each other. And we see in our second example, we see we have 7, 2 6s, another 7, 4, and 3 9s. All the elements are here, 4, 6, 7, and 9. 4, 6, 7, and 9. But we have multiple. But as I said in our previous example, we can have multiple elements in the set as I did in our third example. So this is equal to each other. C, 4, 6, 7, and 9. These sets have the same element and like the same elements in the same order. So these are equal to each other as well. However, if we look at option D, we see that there's a 4, but we're missing a 6. We have a 6 in our first set up there, but no 6 down here. So these is not equal to each other, so the answer is D right here. This brings us to our next concept is how do we represent that an element is in a set? So if we have a set of A's equal to 1, 2, 3, and 4, we can say that 1 is in set A and 3 is in set A with this symbol up above. But let's say that an element is not in the set. So we see from A that 100 is not in the set. So we would say that 100 is an element not in the set using the symbol of element with a slash through it, so not in A. And also, 200 is not in A with a symbol slash through it. This brings us to another concept is how do we represent a set with no numbers at all? So as we said before, in our previous example, A is equal to 1, 2, 3, and 4. This set has numbers, but if a set has no numbers, like for example, B, all we have to do is B is equal to, so it's an empty set with curly braces. Or we can use the symbol up above right there that B is equal to a null set. Or we can just say that B is a null set or B is a empty set. This brings us to our next concept, as I alluded to in the first slide, that sets can be finite or infinite. as we all know, a finite set is empty or element can be numbered 1 through n. So as we see there, A is equal to 1, 2, 3, 4. 1 through 4. We can also use ellipses in finite sets. So maybe we have a set of multiples of 3 up until 99. So we can say that 3, 6, 9, ellipses, 99. In our finite set, we have a first element right there and a last element right there. An infinite set is not finite. As I alluded to in the first example, I used like the prime numbers of, I'll say that our sets in C is equal to 2, 3, 5, 7, and so on. Usually infinite sets are represented by ellipses at the end right there. So it's pretty easy to distinguish between finite sets and infinite sets. This brings us to cardinality. So cardinality is the number of elements in a set denominated by 2 pipes. As we bring up our example again, A is equal to 1, 2, 3, and 4, we see that there's 4 elements in the set. So we can say that the cardinality of A is equal to 4. Another example could be B is equal to 10, 20, so on, and 100. So we see that the set is multiples of 10. So if we just write it out, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, we see that this element has 10. So B is equal to 10. Another good trick to find the cardinality of B was just to divide the last number by the first number. So 100 divided by 10 is equal to 10. So we still get the cardinality of B is equal to 10. In our last practice problem, we're going to use the following sets up here to answer the questions with true or false. So our first one is Q is finite. As we said before, a finite set could be represented by a first element and a last element, and there could be ellipses in the middle. So Q is finite, which is true. P is equal to S. So for sets to be equal, they have to have the same number of elements, and the elements have to be the same number. So we see that there's a 1 in P, a 1 in S, a 9 in P, a 9 in S, a 45 in P, a 45 in S, and a 2 in P, and a 2 in S. So that is true. The cardinality of P is equal to the cardinality of S. So the P and S has to have the same number of elements. As we can clearly see, P has 4 elements, and S has 4 elements. So that is also true. The cardinality of Q is equal to 100. So a trick that I mentioned before that we can just divide the first element by the last element. So if we divide Q's last element by the first element, we do get 100. So that is also true. This symbol right here means that 5 is included in Q. So 5 is an element of Q. 5 is not an element of Q since the set starts at 10 and ends at 1,000. So that's impossible and therefore false. Our last one is 5 is included in a null set. If we previously remember, a null set has no elements. So like B is equal to no curly braces of nothing. So that is also false.